Today we're going to work with factoring polynomials, which basically means we're going backwards, all right? Let's just kind of talk about what we mean by factoring, just that word factoring. What does that mean? Well, if we're factoring something like, let's say, the number 18, if I wanted to factor the number 18, I would be looking for the things that multiply together to get 18. For example, and you guys remember even the factor trees. 2 times 9 makes 18. And then we could even break 9 down further into 3 times 3. So we would say if I wanted to factor 18, it is 2 times 3 times 3. All right? That is all of the factors of 18, and then it's listed as a product. So today, we're going to do the same thing with polynomials. First, I want you to give kind of a subheading here of backwards distributive property. That's the first type of factoring we're going to do. Okay, you'll be asked to factor. And let's say that we have something like this. 6x cubed minus 4x. Now, one of the things a lot of people get confused about is when do I do what? When do I do backwards distributive property? And when do I do what we're going to talk about backwards FOIL, or we're going to talk about the product some way tomorrow or Wednesday. But when you look at this thing right here, you should recognize that it's not what we would call a standard form quadratic, something like this. X squared minus 5x plus 6. Do you see the difference between those two? Okay, this one we have a nice squared term, then an x term, then a coefficient term. We call that ax squared plus bx plus c. Okay, well, this one that we have here is not in that form. It's also not in the difference of two squares form, like x squared minus 49. Okay. So it's not, if you look at these two terms that are in this term and this term, they're not perfect squares. All right, at least not yet. So when you see this situation that we have right here, we need to be thinking backwards distributive property. So let me rewrite it now that I've doodled all over it. 6x cubed minus 4x. And what we're looking for is a common factor in each term. Do you see that there's an x in both terms? Right? And do you also see that there's a 2 in both terms? So we can pull out a 2x, and then what remains is 3x squared minus 2. Doing distributive property backwards, that problem is done. All right? Let's do another one. How about negative 4x squared plus 12x? And I will pause the video and let you do this one. Okay, you've had a chance to work on this on your own. There is a 4 in both terms and an x in both terms. Now, there might be some debate about whether I pull out a negative or not. It doesn't really matter whether you do. I think a lot of you did, so I'm going to pull out a negative 4x. And if you choose to do it that way, you're going to be left with x minus 3 on the inside. Okay? Now, sometimes you may have this type of situation that you need to be aware of. Let's say that we have 2 x squared minus 32. Well, if we take out a 2 out of both terms, I'm left with 2 times x squared minus 16. And immediately you should recognize x squared minus 16 is a difference of 2 squares, which that's actually the next thing we're going to work on in notes. This thing will factor into x plus 4 times x minus 4, and I just have this 2 outside it. Okay? And so that's the way you handle that situation, and you do see some of those, I think, in homework. So that leads us into the next type of factoring, which I just briefly covered, the difference of 2 squares. This is where your root sheets that I gave you will come in very handy. And I'll just start with a very easy one, something like this, x squared minus 144. If you see two terms, if you see a subtraction sign between them, and both the terms are perfect squares, you're thinking that's a difference of 2 squares. This one is easy. Going backwards, we factor it into x plus 12, x minus 12. Easy enough. Another one where we have to combine two things. 3 minus 12x squared. Is 3 a perfect square? No, it's not. So if you see this situation, you want to think, can I do backwards distributive property first? Is there a 3 in both? There is a 3 in both. So if I pull out a 3, I'm left with 1 minus 4x squared. Now, is that a difference of 2 squares on the inside? Yes, it is. So now I leave this 3 out here, and I break this up into 2, and I have 1 plus 2x, 1 minus 2x. So remember that trick. If it's not a difference of 2 squares, see if you can factor something out first with backwards distributive property. Of course, there might be some with fractions, like 4n squared minus 25/49, that might scare you, but they don't need to scare you. This is also a difference of 2 squares, and I don't have to factor anything out first. You know, and when you're doing these problems, I think it helps to go ahead and set up your parentheses. Go ahead and put a plus, go ahead and put a minus. The square root of 4n squared is 2n. How about the square root of 25/49? 5/7. Very good. Okay, so if the top and the bottom are both perfect squares, then you just do the square root of each individually. Sometimes this problem catches people off guard. They don't recognize it as the difference of 2 squares. But it is the difference of 2 squares. It just looks uglier. Look what we have here. Here's my minus sign. I have a quantity squared, and I have a y squared. So this thing is a difference of 2 squares. Set it up the same way. So the first thing that's squared is an x plus 2. So that goes in both places like it always does. The other thing that's squared is a y. So that goes where it always goes. And just like before, it's a plus and a minus. That's all you got to do. Okay, so what you have here is you have this little quantity. I suppose we could put parentheses around it if we wanted to keep that quantity distinct like that. All right. Now, the other shortcut, or factoring shortcut is the square of a binomial. And this is one of the reasons that I was preaching the last couple weeks about being able to do this shortcut in the forward direction. Let's just real quick, let's recall how to do this shortcut, all right, because it's going to help us be able to go backwards, all right. Let's say that I have x minus 7, the quantity squared. Okay, here's the shortcut. We said you square the first term, x squared. You square the last term, plus 49. Then you multiply the two terms together, 7x, and then multiply it by 2, 14x. Whatever this sign is, that's what this is. So your job now, today, is to look for situations like this, where this is a perfect square, this is a perfect square, and the term in between is the square roots of those two perfect squares times 2. All right, so let's look at a couple examples. Of course, we're going to be factoring again. Let's say that I have x squared minus 10x plus 25. This is the square of a binomial. Let's look at this. The x squared is a perfect square. 25 is a perfect square. All right? And the square root of each of those are 5 and x, right? So what's 5x times 2? 10x. So look. This breaks up into x minus 5 times x minus 5, or we can write it as x minus 5, the quantity squared. All right, do you see how that works? You have to think backwards. Let's do another one. All right, you try this one now on your own. 16x squared plus 24x plus 9. Try that one on your own and I'll pause the video. All of you did well in this problem. This is a perfect square, 4x. This is a perfect square, 3. Since this is a plus, this is a plus, and then we have to kind of mentally check. 3 times 4 is 12. 12 times 2 is 24. So it does check that way. So this is the square of a binomial. All right, you need to look for that shortcut. One more, and then we'll be done. The sum difference of cubes. Now this is one where you have to use a formula. There's just no way around it. If I am factoring the difference of two cubes or the sum of two cubes, a cubed plus b cubed, or a cubed minus b cubed, we have to follow a formula. And here it is. This one is a plus b times a squared minus ab plus b squared. The difference of two cubes is exactly the same, but a couple of the signs are changed. It's still an a and a b, it's still an a squared, it's still an ab, and it's still a b squared. Okay, all those terms are the same. The way that I keep this one straight is since this one is a minus, this one is a minus. Okay? And then all of these are pluses. So when you do these, you just follow the formula. All right? So let's do, let's say x cubed minus 27. Well, following the formula, this says a minus b. Well, what, that's going to be x minus what? What is the b going to be? It's going to be whatever was cubed. So in other words, the cube root of 27, which is 3. And then we just follow the formula. X squared plus 3x plus that 3 squared, which is 9. Everybody okay on that? So you just want to follow the formula. Now, what you have to be careful of sometimes, all right, this was example 1. I'm not going to go all the way through this next one. But what if you get one like this? 27x cubed plus 64. Well, you may have to think a little bit more, but it's still not that hard. What is the cube root of this? 3x. So, 3x is going to go here, but what's going to go in this place? 9x squared, right? Okay. So just pay attention to those things. I'm not going to finish that one up. The rest of it's pretty straightforward. All right, so we will stop there for today.